Okay, let's unpack this. Today we're diving deep into, well, what I think is a classic challenge in business. It's about bridging that gap, that communication chasm between the really technical data folks and the strategic side of the house, the business needs. So our theme is all about getting that business intelligence foundation right. Specifically, how do we actually nail down those BI requirements? Our mission for this deep dive. It's threefold, really. First, get a quick grasp on the core architecture of BI systems, what makes them reusable. Second, see how that compares to something different like the CRISP-DM framework for data mining. And finally, the big one, walk through the key steps for actually gathering those requirements, which, let's be honest, means learning to speak less data and more business goals.
Absolutely. And you really have to start by acknowledging that friction. It's almost universal. Ralph Kimball, the data warehousing pioneer, he put it perfectly. He said something like, gathering business requirements is often outside an IT person's comfort zone.
Oh, that quote hits home. It really does, because it points straight at that cultural divide, doesn't it? If you're a data architect, your world is SQL, schemas, latency, performance. But if you're, say, the CFO, you're thinking ROI, competitive edge, market share, totally different language. So when the data analyst meets the business analyst, yeah, that friction point, that's where things can really go sideways for BI projects.
Right. And to bridge that gap, you need more than just good intentions. You need a disciplined architecture, almost like a translator. The whole point of business intelligence, its core purpose, is delivering integrated, consistent, reliable business information and delivering it to a broad group of users. So the architecture, it has to prioritize reusable, cleansed data everyone trusts.
So it's not just about quickly knocking out one report for tomorrow's meeting. It's bigger than that. It's like building a sustainable data factory, almost. So walk us through the blueprint. What does that factory look like?
Well, it typically follows a pretty clear, layered structure, and that's key for resilience and reusability. So down at the bottom, you've got the data staging area. This is where the real grunt work of ETL happens, this extract, transform, load. Raw data comes in, gets cleaned up, transformed, and critically, this happens independently of any specific immediate report request. That cleaned up, transformed data then flows upwards into the data warehouse. Think of this as the central hub, the main repository. It integrates data from all those different source systems. This is your single source of truth, often structured, dimensionally to make querying faster and easier.
Okay, so the warehouse is the central library, the single source of truth. But where do different departments, different users get their specific views, their tailored insights?
That's the next layer up. The information marts, or sometimes called data marts. These are like specialized boutiques drawing from the main library. They're often aggregated subsets of the data warehouse, tailored for specific groups. We might have a marketing mart, a sales mart, finance, supply chain, each pulling what they need from the central warehouse, but packaged just for them.
Got it. And then finally, the part people actually see and touch.
Exactly. The front-end tools, your dashboards, your reporting tools, maybe OLEP cubes for deeper analysis. But the absolutely crucial principle here, the thing that ensures that reusability we talked about, is separation, strong separation. The ETL process, the staging area, the data warehouse, they're designed to be largely independent of any single front-end application. They're about provisioning the data reliably. They aren't tied directly to the consumption layer. So if you swap out your dashboard tool next year, the underlying data foundation, the warehouse, it stays solid.
That sounds incredibly robust. Like you said, building infrastructure that lasts. But okay, our sources also bring up this other framework, CRISP-DM, cross-industry standard process for data mining. Seems like it's used more for focused, specific analytical projects. I'm curious about how that fits in or differs.
Yeah, CRISP-DM is definitely widely used. It's a structured 6-step process, very logical, built specifically for things like data mining, machine learning, predictive modeling. The steps make sense. Business understanding, data prep, modeling, evaluation, deployment. It's often iterative and really tightly focused on building one particular model or answering one specific predictive question.
Okay, I can see that. For a specific project, like predicting customer churn or something, that structured process seems invaluable. But how does it contrast with the broader BI approach we were just talking about? I mean, they both seem to start with business understanding.
They do start there, but the goal and the scope, they diverge pretty quickly and dramatically. Think of it like this. If the BI architecture is building the entire national highway system and the data factory, CRISP-DM is more like planning a single, very precise delivery route using existing roads, maybe building a small access road just for that delivery. The goal of CRISP-DM is usually predictive. It's asking what's likely to happen next. The goal of BI is more about reporting and broad insight. It's asking what happened, why did it happen, looking back and across. But the fundamental architectural difference is in ambition and reusability. In a typical Crispbeam project, the data prep is often project-specific. You grab the data you need, clean it for that model, build the model, use it. Done. The BI approach, because it's building that central factory, requires ETL and staging to be centralized, independent, and reusable across potentially many applications. So BI systems aim for very high reusability. Crispbeam projects, usually much lower reusability outside their specific goal.
Right, that makes sense. One is building that reusable library of truth. The other is checking out one specific book, analyzing it intensely, maybe making notes in the margin, and then you're done with it. Which brings us right back to the core problem, doesn't it? If we're building this whole library, how do we figure out what sections, what books it actually needs? Our sources put it really bluntly. Nobody knows the objective information needs of a customer, not even he himself.
Yeah.
That sounds challenging.
It is the requirements dilemma, and it begs the question, why is it so hard? Why aren't needs objective? Well, because the needs people declare upfront are inherently subjective. They're based on what they know now, their current problems, their current view. It's fascinating, actually. Often the features that end up being incredibly valuable, the ones people use constantly once the system is built, they were never explicitly asked for in the beginning.
So there's this dynamic. We talked about PSH versus PL, right?
Yeah.
Explain that a bit.
Exactly. You've got the I demand. That's the pull. It's subjective, coming from the business users saying, I need this report, I need to see that metric. Then you have the DWH information offer. That's the push. It's capability oriented. It represents what the data warehouse can realistically, objectively provide based on the actual data available in the source systems.
Okay, but wait. If the push side, the DWH offer, is just based on what data you happen to have,
Yeah.
doesn't that limit things? Aren't you just building what the data allows
Yeah.
instead of striving for what the business actually needs strategically?
That's the tension. That's exactly the tightrope you have to walk. You can't just listen to the pull because users often don't know what's feasible, what data even exists, or the quality issues. Their requests might be impossible or misleading. But if you only push based on available data, you might build something technically sound but strategically irrelevant. You ignore the business direction. Kimball's classic recommendation here is what he called the countercurrent flow. Requirements gathering absolutely needs both. You need to integrate a top-down view, understanding the strategic goals, the business objectives, with a simultaneous bottom-up view, really assessing data availability, data quality, the feasibility from the source systems. You have to do both, constantly flowing against each other.
Got it. Top-down meets bottom-up. And to make sure we actually do that systematically, not just talk about it, we have a roadmap. We identified 8 key steps for really rigorous requirements gathering. I want to zero in on the first 3, because honestly, this feels like where things often go wrong right at the start. Step 1, identify stakeholders. Step 2, understand business goals. Step 3, define key performance indicators, KPIs.
Oh, absolutely. Those first 3 are foundational. Get them wrong, and the rest doesn't matter much. Take identifying stakeholders. It's not just listing names on a chart. It's about truly classifying your audience. You need to understand their analytical needs, their sophistication. You know, a CEO probably wants a high-level, maybe visual dashboard, quick glance, big picture. But a power user, maybe an analyst in finance or marketing, they need the ability to slice and dice, maybe even get down to the raw transaction-level detail. Right? Our sources actually break this down. They categorize users based on their needs, kind of on a spectrum. You can start with, like, enterprise users, maybe just accessing basic stuff on a portal or partners. Then casual users who are fine with predefined, maybe static reports.
Then you move up the chain. You get business users. This is often middle and executive management. They need more interactive dashboards, things they can explore a bit for tactical decisions, maybe strategic planning. Their needs often drive the really significant structural requirements for the data marts in the warehouse. And then above them, you have the power users. These folks are comfortable with complex tools. They want to dig deep, maybe write their own queries. And finally, of course, the IT users who are building and maintaining the whole thing. If you design something complex for a casual user or something too simple for a power user, well, you failed step 1 right there. You didn't understand your audience.
Which directly leads to the next point, the absolute necessity to speak business language. You can't possibly understand those business goals, step 2, unless you're precise about the terms the business uses, especially around strategy. We need clarity on things like vision versus goal versus objective, even measure versus metric. Glossaries like TOGAF can help here.
Yes, this is critical. We toss these words around, but in requirements, precision matters hugely. The vision, that's the big picture, the ideal state you're aiming for. Often inspirational, maybe a bit fuzzy. To be the leader in, a goal is more concrete, a high-level statement of intent influenced by that vision, like increase our market presence significantly, still broad, but an objective that has to be specific, measurable, achievable, relevant, and time-bound. Smart. An objective is a milestone towards a goal. Example, increase market share in the Western region by 15% within the next fiscal year. See the difference. Measurable, time-bound. If you capture a goal when you needed an objective, your BI system can't actually track progress effectively. The data won't align because the target was too vague.
Okay, that distinction is crucial. And then we get down to the actual numbers we track. Measure versus metric.
Right. A measure is often just the raw number, the count you get from a measurement. Like total units sold last quarter was 50,000 or website visits were 1.2 million. A metric is usually derived from measures. It's an indicator, often a ratio or percentage, that helps you track progress against your objective. So maybe the metric is conversion rate, which is, say, units sold website visits 100. That metric tells you something about efficiency, directly related to an objective, perhaps about improving online sales effectiveness.
I see. So this whole hierarchy, vision, goal, objective, metric, measure, it fuels that corporate control loop, right?
Exactly. Strategy and planning set the vision, goals, objectives. That drives transactions in the business. Those transactions generate data, which gets consolidated and reported via BI. That reporting provides the feedback and insight, which then informs the next cycle of strategy and planning. If your objectives are poorly defined or your metrics don't align, that whole feedback loop breaks down. The BI system isn't providing real insight.
Okay, this makes a lot of sense. But before we jump into the exciting part, the actual KPIs companies use, there's one more technical concept we absolutely have to touch on. It dictates whether those objectives and metrics are even calculable correctly in the data warehouse. It's the concept of additivity. You mentioned star models rely on this.
Non-negotiable. It sounds technical, maybe a bit dry, but honestly, it's immensely practical. Get additivity wrong, and your reports are fundamentally flawed. Additivity basically determines how you can meaningfully sum up numbers, how facts aggregate across different dimensions like time, product category, region, customer segment. If you misclassify the additivity of a number, every single total, every single aggregated view you generate from the warehouse could be just wrong, dangerously wrong. So there are three types. Added effects are the dream. They're usually event-related things like sales revenue or units sold or maybe website hits. You can sum these up across any dimension. Total sales for the year, some monthly sales, total sales across all regions, some the individual region sales. Simple, clean. Then it gets trickier. Semi-additive facts. These are often status-related like inventory levels or account balances or maybe employee headcount at a point in time. They're only partially additive. You can usually sum them across some dimensions but not others. Time is the classic example. Think about inventory. You have 100 units in stock today. You had 90 yesterday. What's the total inventory over the 2 days? It's not 190. That number is meaningless. You can sum inventory across different products or across different warehouses at the same point in time, but you can't meaningfully sum inventory levels across time. So if the business asks for a monthly inventory report, you need to be clear. Are you summing transactions during the month, or are you taking a snapshot, say, the inventory level on the last day of the month? Huge difference.
Wow, okay. I can see how messing that up would be disastrous. If you accidentally summed daily inventory levels for a month, you'd report vastly inflated asset figures. Management gets a completely false picture.
Precisely. And finally, you have non-additive facts. These can't be meaningfully summed across any dimension. Think about ratios like profit margin percentages or unit prices, or maybe measurements like temperature. You can average them perhaps, but summing them doesn't make sense. The average temperature for the week isn't the sum of daily temperatures. A 10% margin on product A and a 20% margin on product B doesn't mean a 30% margin overall. A well-designed star model, the kind that powers most effective BI warehouses, strongly prefers additive facts because they allow for the most flexible and reliable aggregation. So defining the additivity of every single measure and potential fact during requirements gathering, absolutely critical. You don't want to discover this problem when the dashboard is already built.
Okay, that technical grounding is vital. So now, here's where it gets really interesting, I think. We shift from the necessary rigor of architecture, definitions, additivity, to the payoff, the actual concrete financial KPIs that senior management uses to gauge success. The very success our BI system is supposed to help enable and track. Our sources point to some key financial metric, especially those used by high-performing tech and service companies. If we get BI right, these are the numbers that should hopefully improve.
Exactly. These KPIs, they are the language of the C-suite, the language of enterprise success. Let's start with a big one, operational efficiency. That's often measured by operating margin, usually calculated as EBIT earnings before interest and taxes divided by sales or revenue. It basically shows how well the company is generating profit from its core day-to-day operations after covering the costs of running the business, but before interest and tax.
And for a strong company, particularly in tech or services where margins can be higher, what's a typical benchmark we might see?
Well, the indicative good value, especially for elite firms, can be pretty aggressive. You might be looking at something like 30% or even higher. When you look at benchmarks for companies like Apple or Google in their high-performing periods, you often see operating margins cited in that 31%, 32% range. That signals really strong control over operating costs relative to the revenue they're bringing in. Then related, but slightly different, is gross margin. That's revenue minus the cost of goods sold, COGS, divided by revenue. This zooms in more on the profitability of the actual products or services themselves. How well are production and direct delivery costs managed? For service and tech companies, which often have lower direct physical costs compared to manufacturing, you'd hope to see a healthy gross margin, maybe 50% plus. I think one source mentioned Apple Services gross margin hitting something like 75% at one point. That tells management their core service delivery is incredibly profitable and scalable.
Okay, so strong margins are key. But profit isn't everything. What about how effectively they use what they have, their assets?
Right. That brings us to asset turnover, typically calculated as net sales divided by total assets. This is all about efficiency. How effectively is the company using its asset base, things like its plant, equipment, servers, maybe even intellectual property, to generate sales revenue? For efficient firms, you might see benchmarks around 1.0 to 2.0 times. A higher number means more sales generated per dollar of assets. And this asset turnover, combined with the profit margins we discussed, feeds into the overall profitability metrics like return on investment, ROI, or return on assets, ROA. Strong performers there might show returns in the 20% to 40% range, sometimes even higher, indicating very profitable use of their asset base.
Makes sense. Profitability and efficiency. What about risk? Management must be looking at debt and leverage too.
Always. That's where measures like the debt ratio come in, usually calculated as total liabilities divided by total assets. This gives you a sense of the company's financial leverage, how much it relies on borrowing. It's a key indicator of financial risk. While what's acceptable varies a lot by industry, generally, stronger, more stable companies often try to maintain relatively conservative leverage. Closely related is the equity multiplier, which is total assets divided by total equity. It's another way to look at financial leverage. Again, for strong, perhaps more risk-averse companies, you might see modest leverage, maybe in the 1.5 to 3 times range. You need these kinds of metrics to balance the picture. A company might look efficient on sales, but if it's overloaded with debt, that's a risk the BI system also needs to make visible. It ensures the performance story is complete. So if we were to synthesize the core takeaway for you listening, effective BI, it really demands both sides of the coin. You absolutely need that robust technical architecture, the layer design, the separation of concerns, the focus on reusability, but that technical foundation. It's basically useless without an equally disciplined, systematic approach to gathering the requirements. And that approach has to acknowledge that user needs to start subjective. It needs that counter-current flow, top-down strategy meeting, bottom-up data reality. And fundamentally, it has to ensure every single figure, every metric you plan to track is properly defined, its business meaning agreed upon, and critically, its technical properties like additivity understood before you build anything.
That sums up the connection between the process and the outcome perfectly. The rigor enables the relevance. But let me leave you, our listener, with maybe a final thought to chew on. We talked about that dilemma that often the most useful, most adopted BI features turn out to be things nobody explicitly asked for in the beginning. So the question is, given that reality, how can we structure that requirements process using those systematic steps, the stakeholder analysis, the goal definition, not just to capture the declared needs, but to actively maximize the discovery of those undeclared, maybe latent, but potentially high-value information needs? How do we build a system that doesn't just answer today's questions, but anticipates tomorrow's success? Something to think about.